So today we're going to look at one other exponential formula. They've taken the one I gave you guys, and we're gonna tweak it a little bit to modify it to something which they use in the world of finance called compound interest. And then we'll tweak that even a little bit more, and we'll end up with another formula tomorrow, which is called the continuous growth formula. So let's kind of introduce the idea really quick. So I didn't print this slide for you, did I? You guys don't need to write this. This is just something that I wanted to illustrate for you guys. So it says, suppose you want to invest $1,000 at a bank, and you have 3 banks to choose from. All 3 banks give you 20% interest per year, but they all do it a little bit differently. Which one's the better deal for you? So one of the banks gives you 20% interest, but they do it all at once at the end of the year. So you put money in there, and then at the end of the year, they'll give you 20% add on to that, which, by the way, no bank would do. That's a really high amount. They barely do anything. But that's one. Now let's look at another one. Suppose we had Bank 2. Now Bank 2, you put your money in there, and then halfway through the year, they're going to give you 10%, and at the end of the year, they're going to give you the other 10%. So they give you 10% twice to make 20%, right? And then finally, Bank 3 gives you 5% interest 4 times. So you put your money in, and then after the first quarter goes by, they give you 5%. Another quarter goes by, they give you 5%. Another quarter goes by, they give you 5%, and so on until you get to the end of the year. So those are your 3 possibilities. We're gonna look at how these things play out here. So in this case, for Bank 1, my starting amount is $1,000, right? And 1 plus, this is going to be my interest right here. How much interest are they giving me? 20%, right? So how do I write that as a decimal? 0.2. And that's it. They're only going to do that once. So I have 1,000 times 1.2, which would be $1,200. So I gained $200 out of this deal with the bank, and I make $200 by letting them borrow my money. Okay. Now let's look at 10% twice instead. So what happens is I start with my 1,000, and they're going to give me 10%. Okay, so it's less than these guys gave me at first, but they give me 10% twice. So in this case, this would be 1,000 times 1.1, which would be that. And that makes sense. It's half as much as the other one, right? Because they only gave me half the percentage. But remember, they're going to give me 10% again at the end of the year. So we get to do it again for this one. Oh, oops. Let me back up a little bit. So now what's my starting amount? Yeah, so now at the end of the year, I have 1,100, and they're going to give me 10% again. Okay, so that's going to be that. Which I believe if you multiply it, isn't it 121 with 2 zeros? I think it would be this. Somebody can check me if I'm wrong. 1,210. So which one's a better deal so far? Bank 2, right? 10 more bucks. I don't know if it's really worth the driving if they're farther away. Maybe save some gas money. But anyway, Bank 2 is better. So what do you think is going to happen with Bank 3? It's going to be better. All right. So let's go ahead and do that really quick. So we start by investing 1,000. 1 plus what? What's my percent?
0.05.
0.05. Now, at this point, I'm feeling a tad bit lazy. I don't really want to do this 4 times, and you guys probably don't want to watch me doing it 4 times, right? So But the thing is notice that on this problem, this part stayed the same. I just multiplied by 1.1 here, and then I multiplied by 1.1 here. What's a faster way of getting from the beginning to the end instead of multiplying by 1.1 twice?
Exponent.
Raise it to the second power. So I don't want to multiply by 1.05 4 times. That takes too much work for me. I just want to raise it to what power? 4. The 4th power. And I can get my answer right away. Okay? So let's do that on our calculator really quick and see if it does indeed come out to be a better price, as we would predict. It's not going to be impressive if it is, but we'll try it. Let's see. 1215.51. So you get $15 more. I guess we should go to bank 3. That way we can go to McDonald's one more time. So there it is. What this is called compound interest. Now, why does this end up being? Why do these end up being more than this if they all make 20% anyway?
Because they add more along the way.
Yeah, they add more along the way. That's true. So what's happening is here we're getting 20% of what? 1,000. It's not like we're getting 10% of 1,000 twice. If I did that, then I really would get the same thing. What I'm doing is I'm getting 10% of 1,000 once, and then I get 10% of what? 1,100. So now they're giving you 10% of more. And so you're actually making money on top of the money they already gave you. And that's what we call compound interest. So the more pieces that they break it up into, the more money you're going to make. It's slow, doesn't really make a huge difference, but it does increase more. And that's what we call compound interest. So let me ask you guys another question before we go on to the next slide. So let's say we chose bank 3. And I wanted to invest my money into bank 3 for 3 years. How would I write my calculation out so I can just have a formula and get my answer? There you go. That's right, because you get 4 for every year, right? So if it's 3 years, it's just going to be 4 times 3, which is 12 now. So now you get 5% 12 times. Does that make sense? So keep in mind, this 5, that came from taking 20 and dividing it by 4, right? So I'm telling you all those things because that'll help the formula that we have on the next slide make a little bit more sense. We have a starting amount, which is called the principal. We have our 1. We have the interest rate that they promise us, but it's being broken up into a certain number of chunks. So we have R over N now. Instead of just R, it's R over N. And what happens is every year, N times T, you get that many chunks. And that's what we call the compound interest formula. Okay? And that's actually used in the world of finance, so that's why we kind of take the time to share this special little twist on the exponential function with you guys, because it's actually a pretty useful thing. So some vocabulary that's related to compound interest. Principal is the starting amount. Interest rate is the percentage that they give you. If you see the word compounded, that means how many chunks they're breaking it up into. So you got to get used to some language. Your homework doesn't use this language, but a lot of other applications do. So if you ever see the word annual, that means they're giving it to you once per year. If they say semi-annual, that means they're breaking it up into 2 chunks. If they say quarterly, that's 4 chunks. If they say monthly, that'd be 12. You could even say daily if you wanted to. What would daily be? 365, because it's all by the year when it comes to the annual percentage rate. They go by the year. So here's your compound interest formula. I shared that with you earlier. You take your rate, you break it up into a certain number of chunks, and based on the time, that's how many times you'll multiply that growth factor, and you have your answer. All right, let's do a problem. Example 1. So how much money will you have after 5.5 years if you invest $100 at an annual rate of 10% compounded monthly? So my compound interest formula is this. So the A represents the final amount, the P represents the starting amount, R is the percent, N is how many chunks we're breaking it up into. So I'm looking for A, so I don't know what that is yet, but P is my starting amount. So what's my starting amount here?
100.
So I'm going to circle that, draw an arrow there. And R is my annual percentage rate. So what's my annual percentage rate?
10%.
Which we're going to call
0.1.
0.1. And I'll draw an arrow from there to the R. Now I also need, 5.5. What do you think that's going to be? That's T. That's how many years this is going to be going on for. And then we have N. Now N is how many times it's compounded per year. So what does it say? Monthly. So if it's compounded monthly, it's 12. And that's going to go in two spots. It's going to go here, so you break your rate up into that many pieces. And then it's going to go here because that's how many times it multiplies per year. Okay? So if we just plug all that in and work it out, we'll have our final answer. We would have 100 times 1 plus 0.1 over 12. 12 times 5.5. Now, pros and cons here. I can show you guys how to do this on this blue calculator. I think that's what I would encourage you guys to do. How many of you guys don't have a calculator that's other than your cell phone? Okay, so you two just have cell phone then, right? All right. So the thing is, a cell phone, sometimes they can handle this, and sometimes they can't. Depends on which kind you have. The cool thing about these is that you can type it all in at once. Why don't you guys all come grab a calculator if you don't have one, and I'll show you how to type it all in at once. Now, if you are ever doing this at home, and you don't have access to a calculator, the only way to do this would be like piece by piece. You have to do like the 0.1 over 12 first, then you have to add 1 to it, and so on. You have to do it every piece. But if you have these blue calculators, you can actually type everything in all at once. So what I want you guys to do is I want you guys to try to type this whole thing in all at once on your own. I'll still show you if you need me to show you, but it's actually pretty straightforward. You just have to use your parentheses here. So for this fraction, even though it's not normally in the formula, you're going to want to put that in parentheses for your calculator. How do you get the power? We talked about that a little bit yesterday. You push this arrow, you push y to the x, or x to the y, whichever one it is, I don't know. So let's go ahead and start. I'll walk you guys through it verbally. Start by typing in 100. Do you type it? All right. And then go ahead and make a parenthesis. Then you're going to push 1 plus. Now at this point, they're not going to tell you, so you just have to know how to use calculators. You need to put another parenthesis to block off that fraction. So put another parenthesis facing the same way as the first one. And then type 0.1 divided by 12. Now we're going to push 2 parentheses. 1 to close the fraction and 1 to close the growth factor. Okay? Now you're going to push your power button. On my blue calculators, it looks like this little arrow here. It's called a caret. And then what you're going to do is you're going to put 12, and I think if you just put parentheses 5.5, it'll actually work, but you can also put times 5.5. But try it with just the parentheses and see what we get. And you guys are ready to push equal after that, so. All right, what are we getting?
172.93.
172?
609.
Good. 609? Any other answers?
607. 607.
Oh,
Okay.
interesting. All right. So we got two different answers. I'm wondering if it might be that last part where I told you guys you could use parentheses or not. Let me try something really quick. I think Cameron's right. Here's why. So when you guys type in your calculator this power button, right, and you push 12, did Najib and Abel, thank you. Did you guys just push times 5.5?
Yeah, parentheses.
Okay. So what should also work is if we put this in parentheses, because what that's going to do is that's going to group this whole exponent in one. My thinking is if we don't, the reason why it came out different is probably because after you put power of 12 and then you put times, I'm thinking the calculator probably thought of it like this. See the difference there? So it's calculating all this and then doing times 5.5. Whereas if we put this whole thing, so I'll write it differently in the future, 12 times 5.5. I'm writing it down. You could still do the parenthesis, extra parentheses here, but I think that if we put that piece there in parentheses, we should all get 172.93. Try it again if you didn't. I'm going to try it one more time myself. Yeah. All right, so there it is. $72 after 5.5 years. Quit your jobs now. Who needs to work? You can make $72 in 5 years. All right, so student practice, one for you guys. So go ahead and knock that out real quick.